Seventh grade advanced class. Let's go and knock this homework out for 8.4. The first one is pretty simple. 8 to the 10th or 10 to the 8th power over 10 to the 4th power. We simply take 8 minus 4. That gives us 10 to the 4th power. For number 3, we're going to add our exponents up here. All the bases are the same. 8 plus 3 gives 11. And then we're going to subtract the one below, 2. 11 minus 2 gives negative 3 to the 9th power. You have number 4. Number 5 says, tell whether the triangles are similar. I'm going to say that, well, we got y and 36 and 58 and x. So what we can do, I'm going to say that I can take 90 plus 36 and 90 plus 36. That's going to give us 126. And then we got to take 180 and subtract 126 from it to see if it's going to equal 58. And I know it's not, because right there, I know once I borrow one from here, that's going to be 10 minus 6, and that's 4. And 7 minus 2, that's 5. So 54 does not equal 58. This is not going to make a triangle. So I'm going to erase all this. I'm going to escape here. I'll go back to, I guess I'm actually going to take that there and go back. And now it's going to be no, the triangles do not have the same angle measure. Number 6 is for you to do, to make a line graph out of that data. Now I'm going to do number 7. It says copy and complete the table. So if I'm doing this, the product of power property tells me that I'm going to subtract 4 and add 4. That's going to give me a, see, we're subtracting 4 and adding 4. And that's going to be 7 to the 0 power, because 4 minus 4 is 0. And anything to the 0 power is 1. Number 10 says I have 5 to the 0 power times 5 to the 3 power. Now, this is really going to be, remember, 5 to the 0 power is 1. And anything times 1 is itself, so this should be 5 to the 3rd power. Oh, I'm sorry, that I had to, well, I guess I gave you that one. 8 to the 7th over 8 to the 7th power, 7 minus 7 is 0, and that will give you 8 to the 0 power. It's going to give you 1. Number 11, got negative 2 to the negative 8 power, negative 2 to the 8th power. This is 8 minus 8. This will also equal 1, because that's going to give us 0, right? And any base to the 0 power is 1. All right, let's go to number 13 now. Number 13 says I got 6 to the negative 2 power. That means 1 is going to be above and 6 will be below to the 2nd power. 6 to the 2nd power is actually 6 times 6, which is 36. So just so you get a visual, this is going to equal 1 over 6 to the 2nd. And then 6 times 6 is 36. And that's how they came up with that. All right, next is number 15. Number 15, we see that we have a bigger number down here. So it's going to be 5 minus 3. See, when the bigger number is on the bottom, we subtract the smaller number from it. So that's going to give us 1 over 4 to the 2nd power. Because remember, this would be negative 3 itself, which 3 minus 3 is 0. So that's going to be 4 to the 0 power, which is 1. And then 5 minus 3 would be 2. 4 times 4 is 16. So it should be 1 over 16 should be my answer. Number 17, I see that this is going to be 2 minus 4. So I'm going to have 1 over 2 to the 2nd power. 2 to the 2nd power is 4. So this is going to give us 1 over 4. Now I got number 19. Well, we've got 6 minus 3. That's going to give us 5 to the 3rd power. 1 times 1 is 1. 5 to the 3rd power is 125. So I should have 1 over 125. Let's go to number 21 now. You be the teacher. It says your friend evaluates 4 to the negative 3 power. Is your friend correct? Well, we've got negative 4 times negative 4 times negative 4. That's not how we do this. This is going to be 1 over 4 to the third power, which should give us 1 over 64. The negative sign goes with the exponent, not the base. Okay? Let's go on to number 23. Without evaluating, order 5 to the 0, 5 to the 4, 5 to the negative 5 from least to greatest. Well, I know that 5 to the 4th power is going to give me a positive number, right? Because it's going to keep getting bigger. 5 to the 0 power is 1. 5 to the negative power, that's going to be a fraction. That'll be 1 over 5 to the 5th power. So from least to greatest, it's going to be 5 to the negative 5 power, 5 to the 0 power, and 5 to the 4th power. Each base is 5, so order the exponents. A negative number, then a 0, then a positive number. All right, I got number 25. It says simplify, write the expression only using positive exponents. Well, if I've got 8 and I got negative 2, and I got 8 to the 7th, I'm going to have 8 to the 7th over 8 to the 2nd power. 8 to the 7th over 8 to the 2nd power. So 8 to the 2nd power is 8 times 8, which is 64. 27 says I've got 5b to the negative 2 power over 5, or b to the negative 3 power. Now in this case, you're going to take the bigger negative number, and you're going to be forced to go ahead and move the exponent there. Remember, we only want positive exponents. So this negative 3 is going to come up here, right? And that's going to give us, well, b to the 1 power, because this would be plus 3, right? I'm going to show you really quick here. Since it's a bigger negative number, we're going to add 3 up here. So that's going to give us b to the 1 power. We should have 5b, period. That should just leave us 5b, because b to the 0 power, when I add 3 over here, okay, is going to give us a 1. So anything over 1 is itself. I should have 5b for an answer. Number 29. I got 3d to the negative 4 power times 4 to the d, 4 times d to the 4th power. We know 4 minus 4 is going to be 0. D to the 0 power is 1, and 3 times 4 is 12, and 12 times 1 is 12. I'm thinking this is going to just be 12. And it is. Number 31, we got 3 to the negative 2 power, k to the 0 power, and w to the 0 power. Remember, we can only do this with the same base. So since this is negative, this 6 is going to come up here. This would be plus 6. So we should have, well, 3 to the negative 2 power. That's going to come down here. A lot of this is going to get moved here. Let's see. Only positive exponents. Well, that's going to give us W5. Remember, this is 0, and this is going to be plus 6. And actually, this is W to the 6th power over, and that's why that came up as adding 6. W to the 0 power is 1, so it's 1 times W to the positive 6. And remember, K to the 0 power is 1. And then this 3, since it has a negative exponent, will bring the 3 down here, okay? So for those that might get a little confused what I'm trying to say, this is going to equal the 3 to the 2nd power is going to come down here. This is to the 0 power, so this is 1. That's going to get multiplied to W, well, actually 1 again, right? And then times W to the negative 6, so that's W to the positive 6. Anything times 1 is itself, and that's why we got W to the 6th power over 3 to the 2nd. 3 times 3 is 9. That's how we got that one. Let's move on to number 33. How many millimeters are in a decimeter? Well, a millimeter, we're talking lengths here. A millimeter is 10 to the negative 3 power. So that's going to go ahead and give us 100 millimeters. All right. You might be thinking, how did you get this? So let's go ahead and remember that if we have 10 to the negative 3, remember how many millimeters are 1 decimeter, right? So the decimeter is bigger. That's going to be 10 to the 1. And then we're putting this to millimeters, right? So this is going to be 10 to the 3 on the bottom. So I guess it would kind of look like this. We'd have, because this is a decimeter, 10 to the negative 1 is going to be equal to 10 to the negative 3. And of course, to make this positive, we're going to have to bring this up here. So this would be positive. We'll have to add 3, which means we'll add 3 over here. And 3 minus 1 is 2. That's how we got 10 to the 2 power, right? And 10 times 10 is 100, so it's 100 millimeters. All right, I've got number 35 now. How many nanometers are a millimeter? The nanometers is 9, right? To a millimeter, which is 3. That's going to give us 1 million, right? Because we're going to have 6 zeros there. 9 minus 3, right? Will give us 1, 2, 3, 4, 5, 6 zeros. So that's 1 million nanometers. Let's go to number 37. You have number 38 to do. Number 37 says a bacterium is 100 micrometers long. A virus is 1,000 times smaller than the bacterium. Using the table above, find the length of the virus in meters. All right. So remember, a bacterium is 100 meters long. A virus is 1,000 times smaller than a bacterium. So we're going to have 100. We're going to multiply it to the bacterium, because remember, it's 1,000 times smaller. So it's 1/1000th, right? That's going to be 100 over 1,000. We get rid of each 0 that's on top. And that gives us 1 over 10 micrometers. The virus is 1/10 micrometer long. So remember, there it's saying use the table above to find the length in virus in meters, okay? And we're just going to go back here. Remember, the table is the one that we were at, but I think all the information is really here. So we're talking about 10 to the negative 6 power, since we're saying to use that table. Find the length of the virus in meters. I'm just going to make sure this isn't very good. So this is going to give us this is going to be 10 on the bottom, right? 1/10 times 1 over 10 to the negative 6, so that's going to be positive 6 down here. So that's going to be another 10 added on, so that's going to be 10 to the 7, right? So that'll be 1, 2, 3, 4, 5, 6, 7 zeros here. And that, of course, is going to be, once we put it back into decimal form, that'll equal 0.12345 zeros and then 1, or 10 to the negative 7, because remember, we start the decimal here and we go back 1, 2, 3, 4, 5, 6, 7. He says is the answer to part A less than, greater than, or equal to 1. Well, the length of the virus, since it is 10 to the negative 7 meters, 1 micrometer then is equal to 10 to the negative 6 meters, which is greater than 10 to the negative 7. Remember, this is going to give us a smaller fraction, right? The more negative, that means it's going to go on the bottom. The more zeros it's going to be there. So this is going to be bigger. The answer to part A is less than 1 micrometer. All right, number 39. Just going to go back here. This was 37. I'm not quite sure what happened to 38. I'm going to have to find it, bring it back to you. 39 says, describe how to rewrite a power with a positive exponent as a fraction with a power in decimal. Use the definition of negative exponents to justify your reasoning. Well, This is a sample answer. Write the power as 1 divided by the power and use a negative exponent. So if a to the n equals a to the negative n, so this would equal 1 over a to the negative n. All right. Number 40 is yours to do. And that was it. I'm going to try to find that last one. I found out what happened when I gave you the answer to 37. 38 was actually the slide before it. So now here's number 38 for you. 39 is the one I just went over. 40 is for you to do. And that's all of it. See you in class for grading. Have a great night.